Today we are speaking with Harshill Parikh, co-founder of the AI-powered application security startup Tromzo. Hi, Harshill.
Hi, Dennis. Thanks for having me here.
Harshill, you work with large enterprises that have huge code bases that inevitably face numerous security risks. In your opinion, what are their biggest challenges when it comes to application security?
That's a good question to start with. We are an application security company. I've spent many years, even before starting this company, in this space. The challenge more or less has been consistent, which is when you have large enterprises, large code bases, number of different developers, teams working on various different things, trying to push features out. Security is sort of one of those things where it's important, but it's not always the top of the mind for a lot of development teams because they're trying to push that new feature, release the product, but it's actually pretty critical to address security early when you're writing the code base or even designing it rather. So it's sort of one aspect of security that's challenging is that cultural challenge where how do you incorporate good security practices, good decisions early on, so it becomes cheaper, faster to maintain good security hygiene. But that's not always the case, right? We always have security related concerns come up after things have been deployed, after code has been built. So it becomes a sort of prioritization issue, right? It's just like any other bug, any other hygiene, where how do you really prioritize this important security fix as compared to pushing off a new release or a new feature or what have you. So I think it becomes a trade-off, but balancing that act of good security hygiene, operational hygiene with the velocity or the new feature development that developers typically want to have. How do you really balance it? I think that becomes an interesting and a challenging position for most companies.
And if there were just a few, vulnerabilities to fix, that probably won't be a challenge, right? So when there is so many, vulnerabilities in your dependencies, et cetera, then it becomes a problem.
Yeah, exactly. And unfortunately, it's also the reality of the security world we live in, which is there's just a lot of noise, right? There is an overwhelming volume of potential concerns that may or may not be real. And you don't know until you spend enough time investigating each one of those concerns. So then the decision becomes even more challenging. Like, do you address every single potential concern? Or do you spend time and only address the ones that are really concerns for your particular business? And the easy choice is to not do anything, but that's also very dangerous, right? But
Right.
unfortunately, a lot of people just take that easy decision out because of this cycle of high volume, noisy security concerns and developers not having enough time or security people not having enough time to actually make good decisions here.
Well, when there is so much work to do, people always seek ways to automate things. How did security teams work before, and what is changing now with AI?
That's an interesting question. I mean, look, security has been trying to get better, more secure software development practices in place for 20, 25, 30 years. But this has always been a challenge. We've tried, as an industry, we've tried many things. It started with scanning your code bases with all these scanners that'll find problems, right? Like earlier back in the day, you would take your code bases or binaries or what have you and run all types of different scanners, generate large Excel spreadsheets or PDF reports, and then go back and fix it. That process changed over a period of time with more CI/CD integrations or even more IDE integrations, where now multiple different scanners run earlier in the life cycle. So that was a shift that started, 10, 15 years ago or so. That has continued to evolve with more security shifting left to the developers. Now there's a lot of CLI tools that developers can run on their own laptops. Also, as a part of your PR or your CI/CD process, there's many things that happen. I think the undeniable fact is that development, software generation, code generation is increasing in volume, in velocity, as well as now being done by AI agents. So that's like nobody will doubt that, right? Now, with that change, what does it mean for security? Does it mean we're just going to run more scanners? We're just going to find more problems? that doesn't sound like a solution to the problem. It just sounds like creating more problems. But I think the industry in this weird phase where we got to figure out what is the right way to make this a scalable solution. Theoretically, if AI agents get better and better at writing code, I'm hoping and I'm pretty confident that they will also get better and better at writing more secure code. So if that gets better, then as an industry, we got to figure out a way to fundamentally direct the AI agents in a direction where they're intrinsically writing architecturally sound, secure code that also meets your, syntactic practices and things like that. So I think the future is very bright because like if you're automating code generation, then if we invest in automated secure code generation through AI agents, then a lot of problems get solved. Obviously, new problems will evolve, which we don't know yet what those problems will be. But I'm very hopeful of this AI native future.
But what about attackers? They certainly use AI as well. What new type of threats have appeared recently?
Yeah, that's been an interesting and very evolving space. I mean, we've seen from simple things, we've seen attackers use AI to write very sophisticated phishing emails, which are really, really hard to detect. But that's the obvious simple thing, right? Like you can also expect more AI voice-based attacks happening because your voice models can simulate somebody else's voice. Like if they capture our audio recordings over YouTube or what have you, it's very easy to replicate our audio using agents or AI capabilities. So phishing voice calls using my voice or your voice becomes very easy to do that. So we haven't seen a lot of that, but that's going to happen. We know that. From a more technical perspective, because a lot of these decisions are being made by AI agents, for example, if you're using a coding agent to write code, it will likely determine what dependencies to use, where to source it from, and so on and so forth, without a lot of human intervention. In that case, we've seen attacks where the upstream dependencies get poisoned and AI agents just multiply the distribution quite a bit because now you have massive distribution of those poisoned artifacts from upstream. So those are again just simple things that change that just gets faster, cheaper, better for attackers to start attacking. And then exploit generation becomes very, very easy because writing exploits for vulnerabilities also requires coding, and now you have coding agents that can actually do it. So that it's the magnitude and sophistication will increase. I think it's just up leveling attackers. So anybody in their mom's basement can become slightly more sophisticated without much investment into learning complex attack techniques. So it's going to get interesting, but it's a race, right? Like, how quickly can you use AI as a defender in an effective way before the attackers get better and better? But it's not going to stop anytime soon, right? It's both sides, both
It's
parties
always
will continue to get
been
better.
like that.
It's
At a
just a
mouse
different
game.
technology that's available now, but it's different solutions and different attack vectors.
Yeah.
Which is why it's great to be in cybersecurity, right? It's never ending. It's
Yeah, yeah.
amazing to see that.
That from the AI can automatically triage vulnerabilities found in customers' code bases. How accurate is that?
Look, it's very, very accurate in the sense that it's almost human level accuracy, and we didn't
Really?
achieve in day one, right? And when I say human level, there's um, various seniority levels of humans. So there is the entry level intern level. There is also like, somebody who has 4 to 5 years of experience engineer type of level, which again, everyone makes mistakes. Everyone has different perspectives. And then there's a very senior seasoned architect with 20 plus years of experience. They make decisions a little bit differently. What I like to say is Tromso can very effectively make decisions similar to like a senior engineer with 5 to 7 years of experience. The decisions that it can make, we've seen 95% of accuracy in a lot of cases. I don't think anybody using AI can claim 100% accuracy. That would be not accurate, and we should all recognize that. But the fact that by making it very specific to certain tasks, tuning it and training it and using evals and frameworks that make it very, very good at a few things we've been able to achieve that in those tasks of triaging and remediation. So it's a very exciting time to be in this space because this has never been possible before, to replicate thinking, to replicate reasoning, to go and investigate facts based on reasoning questions. Only humans were able to do it, but now that technology unlock is there, and it's just amazing.
Anyway, despite all efforts, AI still makes mistakes occasionally, and you basically can't blame it. It's just a machine, right? So how would you recommend security teams use such tools, given their nature?
Yeah, I mean, honestly, like I would want it to behave more like machines. Machines don't make mistakes. You tell a machine to do something, and machine will do exactly what you told it to do. But this is not exactly a machine where it's got thinking and
Yeah.
it has its own way of coming to an inference. But I think we should really think of this as what would you do if you have a junior engineer in your team? You can't expect a junior engineer to be 100% accurate all the time. And
Right.
that's just
But they
human,
can
right?
learn.
They can learn, exactly. So that's the opportunity that we have, which is let's be a little bit more accommodating with the AI capabilities. It's not going to be 100% accurate. It's not going to be, you shouldn't also expect, you know, unacceptable levels of accuracy here. So it's got to be reasonably accurate. It's got to solve a legitimate problem for you. But then it's going to be a process where you have to train it. You have to tell it how to make the right decisions. And the expectation is, yes, it should over a period of time get better and better at making those decisions. But it's still, we're in the very early innings of AI, and I'm by we meaning industry in general, right? So we're just starting to see real world applications of those things. But that's what I would like to at least train the audience on, which is let's be a little bit more accommodating on this. Don't expect 100% accuracy, but it's 18 to 90% accuracy is better than 30% accuracy, which is what used to be true in the world of cybersecurity before, right? So it's a huge leap as compared to the traditional tools. It's not 100% accurate, but to accommodate for that, you have to make sure that you have human in the loop. You are overseeing the complex edge cases, and you are maintaining oversight of these decisions rather than letting it run autonomously all the time.
What about unit economics? How much does it cost to triage vulnerability with your solution?
Yeah, that's a good question. I mean, look, I mean, I can't disclose the exact cost of it, but at the same time, what I would like to compare it against is if a human was to do it, which is what our
Uh-huh.
customers do today. Humans typically spend, I don't know, half an hour to 45 minutes per vulnerability triaging it if they were to do it manually, which is very, very expensive. It's so expensive that most people only do it for very, very selective issues, and it's not efficient, it's not effective because they miss a ton of things. But when you do that with AI, it is 10x to 20x cheaper than doing it manually. Yes, it's not free. There are compute costs, there is inference cost. All of those is a part of the calculation, but it is orders of magnitude cheaper than what you would spend if a human was to do it. And that is as of today, right? The one thing that we all know from the past few years of AI development is that inference costs are getting cheaper and cheaper every single day, every single year. So it's going to be significantly better costs and unit economics on these tasks over a period of time, right? So it's that's something that I'm really not worried about, because the bigger challenge for us is to actually make a solution that works and solves a problem with very high levels of accuracy. Like that's the fundamental problem. The unit economics getting better and better, that's just going to happen. Like there's no debate about that. It's just going to get better and better. But if we don't focus on building a solution that actually works, that's not going to solve by itself.
Are there any other challenges besides accuracy?
I think scale is a big challenge, like it's like when you start running workloads at an enterprise scale, there are a lot of limitations on inferencing. Like you have to build an architecture for it. It takes time. LLMs and using inferencing with large language models is not exactly fast, but if the users are trained on using traditional software, which typically is very, very fast. Then the user expectations change, especially if you're doing inferencing across tens of millions of tokens every single day. Like you got to figure out your infrastructure layer, which is not exactly easy. You got to provision capacity. You got to make sure that you optimize all of those things. So I think there are not many cases in the world where really intense AI workloads have run at enterprise scales. I mean, obviously the foundation model companies are doing it, but it's not very common for most software companies to be able to do it. So I think it's a challenge to get AI workloads running at the scale, performance, and quality equivalent to a traditional software.
That's certainly a challenge. All right, I think that's all I have for today. Thank you for joining us and for all the insights you shared. For anyone interested, I'll put the link to Trom's in the video description below. And I think that's all for today. See you in the next video.
Awesome. Thank you, Dennis. It was a pleasure.